one of the gas turbine engine version. This is a Ellison J35 engine. Okay, normally used on military aircraft. Okay, so when you talk about gas turbine engine, normally we have four types of turbine engine. One is called pure turbojet engine. This is a turbojet engine. We have a turbofan engine. Normally you look at the bigger aircraft, public transport aircraft macam Airbus, A320, 737, all those are turbofan engine. Okay, this is a turbojet. We have a gas turbine engine, but it's a turboprop engine. That means gas turbine, but used to power the propeller. Okay, that is a turboprop engine. And then we have a turbo shaft engine, the one you look here at the helicopter. This helicopter engine is a turbo prop engine. Sorry, turbo shaft engine. Okay, so when you talk about the basic gas turbine engine, the principle, okay, this is your, well, depend on the aircraft. This is a old engine version. The pani at the front here, there's a gearbox, but normally nowadays the gearbox is somewhere underneath the engine. Okay, so this is where your air coming in. Okay, the starter there, the starter generator. When you crank the engine, that starter will spool this shaft here, the compressor here. Okay, and the compressor will compress the air. Okay, so that air will go through after this is a compressor, and this compressor comprises of various stages. Okay, depend on the engine. So if you can see here on this compressor here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 stages of compressor. So this compressor is driven by this turbine. We have 11 stage, and this compressor is driven by this turbine rotor here. Okay. This is a turbine nozzle, this is a turbine rotor, so it become one stage. Okay, a stage of nozzle followed by a stage of rotor, that become one stage. Whereas for the compressor, a stage of rotor followed by a stage of stator blade, that become one stage. Okay. So once you crank the engine, the starter will crank the engine. It will engage this spool here. The spool here rotate. Actually, the starter will rotate this shaft, and that will rotate the compressor. Initial. Okay. So once you have enough air coming in, okay, normally the engineer or the pilot will look at the rotational speed of this compressor. Normally, let's say kalau if this compressor is let's say max speed dia about let's say 50,000 RPM. So at about 10% RPM, the pilot will introduce the fuel. Okay, so you don't have to be until 100%. 10% is enough. Okay, so depend on the engine. So once this air is being compressed, it go to this diffuser duct. It go into your combustion chamber. Okay, this is a multiple can combustion chamber. We have three types of combustion chamber. This is the older version here. Is a multiple can. You can see one can here, one can here, one can here, multiple. Some are can annular, and some are annular. Annular is just a space, okay, where you burn your fuel and the air mixture. So you have air here going into your combustion chamber. Okay, not that all air being used for combustion. It's only about 12% is being used for combustion. Okay, the rest is used for cooling and dilution of the air because it's too hot inside here. Okay, the temperature can be 1000 degrees Celsius, something like that or more. Okay, so once the starter rotate this shaft, the compressor will start to spin, and it will compress the air at about 10% RPM. Let's say 10% of this speed, air will come into here. Then the pilot will introduce the fuel. Fuel masuk through this fuel spray nozzle. Okay, so once you have a proper mixture of fuel and air, there's about 15 parts of air to 1 part of fuel. Then ignition, then you have an igniter to ignite the fuel. Okay, you have an igniter to ignite the fuel. So once the ignition take place, so through this propagation tube here, you can see here, so that api will propagate. The combustion process will propagate from one can to another can. Okay. Yeah. So once you have once ignition light up takes place, okay. So what happened? The hot air will go through here, will go through the turbine, and because that few air mixture, they are the energy, the heat energy. So that heat energy is actually a kinetic energy that will be extracted by this turbine to drive the compressor. Okay, so the turbine will drive the compressor, depend on how much energy here. Okay, the faster the turbine, let's say if the turbine, you need the turbine to go more faster, then you have to burn more fuel. So okay, so once that combustion takes place, there's a energy in this combustion air or gases. So this turbine will extract that energy to drive the compressor, and then this turbine will start to increase the speed. Okay, increase until such speed that you don't need a starter anymore. So the starter will cut off. So when the starter is cut off, so this engine is self-sustained. That turbine, because of the heat energy here, will start to drive the compressor. So if you want to increase the speed, you have to increase the amount of fuel. So all that will be controlled by your fuel system. Okay. So whatever remaining gas here, okay, remaining gas here will come out through here. Okay, you can see this is your exhaust. Okay. This is your exhaust cone. Okay. You can see the air, once being discharged by this turbine, it will go through your nozzle. Okay, you can see the nozzle is convergent shape. Okay, convergent. So what happened to the velocity? Velocity will increase. So if you apply the Newton third law, for every action force, there's always equal and
opposite action.
So this one, well, you put on the aircraft, it go forward.
Go forward.
But if you run now, it go anywhere. Just not being controlled. Okay? So normally we fit on the wing, mounted on the wing. You can see there, mounted at the tail area. Depend on the aircraft. Okay, apa lagi? Itu je lah. That's about